Hello everyone. Today I'm going to talk about ZOZOTOWN application modernization with Istio. I'm Yoichi, tech lead for ZOZOTOWN platform SRE at ZOZO Inc. Here's the agenda for today. I will start with a brief introduction. Then I will focus on ZOZOTOWN application modernization. At the end, I will have a quick recap. So about ZOZOTOWN. ZOZOTOWN is the largest fashion online shopping website in Japan, where more than 830,000 items are available for purchase as of December 2021. It was launched in 2004. It was a monolithic e-commerce application built on-prem. It leveraged pretty legacy stacks like VB and classic ASP for server-side scripting. I don't know if you know those things. It also leverages Microsoft SQL Server for database. It contains tons of business logic in database stored procedure, which make each component tightly coupled. ZOZOTOWN grew with the same application architecture until about 4 years ago. In 2018, in order to scale our business, we started a modernization project called the ZOZOTOWN Replace, where we migrated monolithic application to container-based microservices on cloud. So we incrementally migrated a legacy application by gradually replacing specific function with a new developed application on cloud. That's what's called strangler application pattern. First strangler application was the production API, as we thought it was the most effective application to migrate. Then in 2020, to accelerate our migration, we implemented the API gateway in Go language. We call it ZOZO API gateway. Here's how we replaced an existing component with the new strangler application using API gateway. API gateway can act as a reverse proxy. In this example, we replace search component. First, instead of the directly sending a request to the existing search component, we made the client send a request to it through API gateway. Then, once the search API is ready, we made API gateway start routing request for search to the new search API. Same as search API, we migrate the ID component in the same way. That's basically how we did the migration using the strangler application pattern. But as we proceeded the migration, we saw increased operational complexity and overhead. For example, API gateway had to include various networking features to meet each service requirements. That actually added a developer overhead and made a gateway more complex. Also, each service has to implement networking feature and configuration for service-to-service communication. Inconsistent service networking added both SRE and the developer overhead and increased the operational complexity. It's not only service-to-service communication, but also service to external service communication. To resolve those problems, we decided to adopt Istio. In 2021, we introduced Istio onto our production cluster. So for enabling Istio on our microservices architecture, again, we took a gradual migration strategy. We introduced Istio to one microservice at a time. And we took canary deployment strategy to achieve zero downtime deployment for the migration. We leveraged two different features for the migration of microservices pod and API gateways pod. Let's see how we did the migration of microservices pod. For canary deployment for each microservice, we leveraged API gateways weighted routing feature. In this example, we migrate service A. First, we set up the new service A, which is Istio proxy injected. At this time, we configure to route all traffic to the existing service A. YAML file in the right side is the manifest to define API gateway routing. Then we gradually increase the traffic way to the new service A by applying new routing manifest. That's how we enable Istio on all microservices pod. Now the service to service and the service to external service communication can be consistently handled by Istio. But as you can see, gateway to service communication is still handled differently. So we decided to enable Istio on API gateway pod as well. Before enabling Istio on API gateway, we refactored API gateway to fitting with Istio. Those are API gateway's original features. As you can see, there are a common feature between API gateway and Istio. So we offloaded some of the common feature in API gateway to Istio. Features in the area surrounded by the dotted line are the one we initially offloaded to Istio. So next, let's take a look at how we did the migration of API gateway pods. Actually, we had a AWS application load balancer that's set in front of our API gateway. For canary deployment of the API gateway, we leveraged weighted target groups feature of application load balancer. First, we set up the new API gateway, which is Istio proxy injected. And also we set up the ingress gateway to manage incoming traffic from outside the cluster. At this time, we configure to route all traffic to existing API gateway. YAML file on the right side is ingress manifest. You can see special annotation for the load balancer controller. You can define traffic where of each target group with it. Then we gradually increase the traffic way to the new ingress gateway by applying a new ingress manifest. That's how we enable Istio on all API gateway pods. So finally, consistent service networking was achieved when not only service to service, but also ingress and egress traffic can be handled by Istio. Those are examples of Istio custom resources. SRE teams for each microservice and API gateway are able to configure each service networking with the same set of the English Istio custom resources, such as virtual services, destination rule, things like that. That's basically all for our migration, but this is not the end. We are working on further Istio adoption. For example, we've just started adopting progressive delivery. We have a plan to offload more features of ZOZO API gateway to Istio. Also, we are working on more automated and safer Istio upgrade. We also have a plan to expand service mesh across multiple Kubernetes clusters. So let's recap for the migration. We did a gradual migration from monolith to microservice using Strangler application pattern. As we proceeded the migration, we saw increased operational complexity and overhead. To resolve those problems, we decided to adopt Istio service mesh. We refactor API gateway to fit in with Istio. We gradually introduced Istio to our production cluster using canary release deployment. Now, we are on further Istio adoption for better resiliency and DevOps experience. So that's it. Thank you for watching. If you have any question, please reach out.